So we're finishing up the year with concentration units. You are going to need to know these no matter what other science class you take, even if you don't get tested on them. There's 3 of them that you ought to know. There's 2 of them that we have enough time for. One is, okay, when you saw the video, they talked about concentrated and dilute solutions, and we need a more quantitative way to talk about solutions. So we're going to talk about 2 units. As I said, one is molarity. Molarity is given the symbol capital M, and it is defined as the moles of the solute divided by the liters of solution. For what it's worth, most people will tend to abbreviate solution, S-O-L-N. They just do. Okay, solute, if you remember from the previous video, is whatever has been dissolved. It's whatever you have less of, generally, but it's the thing you don't see anymore. Your solution is the, well, let's just write this down up here in case you've forgotten. The solution is the solute plus the solvent. So solution is solute plus solvent, and the solvent is what does the dissolving. So that's molarity, and that's used very often. Another thing you might use is percent by mass. And that is simply defined as the mass of the solute, usually in grams, divided by the mass of the solution, same units, grams, if you've got grams for the solute, times 100. The mistake people make most of the time on this one is they tend to put the mass of the solvent down here and not the solution. Both of these have solution on the bottom, which is, of course, the solvent plus solute. So let's do a problem. Let's find the molarity of 20 grams of NaCl in 2 liters of solution. Well, first of all, we need to convert this to moles because molarity doesn't have anything about grams in it. So we take 20 grams of NaCl and we divide by the molar mass. 1 mole of NaCl is equal to 58.5 grams of NaCl. So taking the mass, dividing by the molar mass, that gives me 0.342 moles of NaCl. I'm going to turn this a little bit. Okay, so 0.0342 moles. So molarity is moles per liter, so I'm going to take 0.0342 moles and divide it by the 2 liters of solution that I happen to have. That gives me 0.171 molar solution. So we would say that is molar, like your teeth. Let's try another one. Okay, I want to know how many moles of solute are in 4.5 liters of a 0.01 molar solution. All right, let's take what we have. We've got liters, and we can break molarity up into 0.01 moles in every 1.00 liter of solution. If I have 4.5 liters of solution, those units will cancel, denominator and numerator, and I'm left with moles. So I take 0.01 times 4.5, and then I divide it by 1, and that gives me 0.45 moles of solute. I'm gonna...
0.04.
Decimal place is in the wrong spot. So forget that decimal. 0.045 moles of solution. Let's take a look at percent by mass, and then we are done for the year. Percent by mass. I have 3.5 grams of KBr in 200 grams of solvent. KBr is polar, it's ionic, so the solvent's probably water. Percent by mass, if you remember, is grams of solute divided by grams of solution. So to get grams of solution, I have to take 200 grams of solvent plus 3.5 grams, of my solute, and that gives me 203.5 grams of solution. So to find the percent by mass, it's 3.5 grams of the KBr in 203.5 grams of solution, all times 100. So I'm going to take 3.5, divide by 203.5, multiply by 100, and my percent by mass is 1.72%. You can do one other thing with percent by mass. Suppose you know the percent by mass. You have an NaCl solution is 6.7% by mass. And I want to know how many grams are in 450 grams of this solution. How many grams of NaCl, sorry, are in 450 grams of solution. I don't know another way to do this except kind of almost cross-multiplying. You know there's 6.7 grams of NaCl in every 100 grams of solution, because I just told you that. That's what this is. And I want to know how many grams of NaCl are in 450 grams of solution. So to do this, I'm going to divide these two and multiply by 450. That gets x by itself. So I end up with 0.067 times 450 grams of solution. And let's get rid of this. Let's just get rid of that. Anyway, multiplying those two together, I have 30.15 grams of NaCl and 40.5. So that's just a ratio. And that's it for the year, guys.